Hello my shimmering stars, today I Shaurya Grover welcome you all to this amazing platform of PW English. So students, I welcome you all to your Nexus batch. And ma'am, what are we going to cover today? So students, here we are going to cover the overlapping part and we are going to cover the hybridization part as well. So in hybridization, we do have some concepts like, hybridization from the structure or hybridization with regard to calculating with the help of atomic orbitals, number of atomic orbitals which are combining, forming number of hybrid orbitals, and then seeing their geometry, their bond angle, their structure. We are going to do in such a way. Yeah, students. So over here, when I am talking about this particular part that we are going to cover today, this part, let me tell you students, where we are understanding about hybridization, we will be seeing that how sp hybridization is seen in the cases like BeCl2, okay, how hybridization is seen in the case of CH4. So we are going to take certain examples. For example, SF6. In actual, how are they going to look alike? So we are going to draw with the help of their electronic configuration. Then we will be doing the hybridization process. We will be obtaining the hybrid orbitals. Then we will be defining their shape based upon the previous session that we have done. In the previous session, I told you the types of hybridization such as SP, SP2, SP3, SP3D, SP3D2, in which we got to know linear shape, trigonal planar shape, tetrahedral shape, octahedral shape, all of these. So one by one, we are going to proceed with that. Now students, let us start this session with a beautiful smile. So students, as you very well know, this is going to be your lecture number 5 for this particular session, for this particular chapter, that is going to be your chemical bonding, everybody. Yes, now let's start that. First of all, ma'am, what are the topics we are going to cover? So yes, we are going to complete hybridization in depth. We are going to complete hybridization, okay, hybridization part 2, and we are going to practice a lot of questions. Today we are going to practice a lot of questions based upon the overlapping part, based upon the hybridization part that we have done till now, based upon the valence bond theory, okay. So we are going to do questions based upon them as well. Now students, starting with the very first part is your friends over here, barium and calcium. Yes. So again, calcium says that, hello my shimmering stars, have you revised yesterday's class? So yes students, revision is really very essential, as I always say in my classes, that you can understand a subject, but before, if you're not revising it again and again, you will forget it at some instance of time, right? So for that, revision is really very, very important, students. Now coming to your friend over here, barium with us. Basically, see, barium says that now we are going to start with the hybridization portion. Yes, everyone. So students, let us start with the very first portion of ours, that is going to be hybridization. In the previous part, I have told you the types of hybridization though. Now I am going to explain you one by one each one of them. Starting with the very first hybridization that I have is sp hybridization. Which kind of hybridization, students? Here I am having sp hybridization. Now in sp hybridization, how many hybrid orbitals are present? First of all, we have to see that. How are we going to check that? Let us understand this in depth. For example, students, s and p orbitals, they both are overlapping. They will form sp. Only one p orbital is overlapping, right? See, if it is sp2, that means 1s and 2p orbitals. If it is sp3, 1s and 3p orbitals. Getting my point? So here you can see that how many hybrid orbitals are formed. It depends upon how many atomic orbitals are combining with each other. So let us consider that we have one s orbital. S orbital, you very well know, is spherical in shape. And we have one p orbital, ma'am. This is p orbital, right? So ma'am, when S and P basically are going to undergo the hybridization process, what are we going to obtain? See, we generally obtain this kind of structure. But in actual, in the previous class also I told you, in actual it won't look like this, but it will look like this. So what are we going to obtain? We are going to obtain two orbitals. We are going to obtain two sp orbitals. Why? Because two atomic orbitals, one s and one p are combining, so they are going to form two hybrid orbitals. Now what are these? Ma'am, these both are hybrid orbitals. This is the same thing, but in actual the representation looks like this. In actual the representation to look like. Now what is this bigger region and what is the smaller region? See, this bigger region basically is this overlapping region. This is the overlapping region which in actual is in a larger content with regard to the smaller ones. With regard to these, it is, you know, in a huge amount. So in actual it looks like this. Now that means before hybridization you had these two atomic orbitals, and after hybridization you obtained this. Now when they both will combine, let us see their combination. When they both will combine, in actual this is your first one, right? In actual this is your first one, and in actual this is going to be your second one. Are you able to understand? This is going to be your second one. Now, if you'll observe the angles, like if you'll create an axis over here, what is the angle? Bond angle. So, the bond angle that we'll see over here, ma'am, is 180 degree, and this kind of geometry, students, is referred to as your linear geometry. Right. Now I am taking an example in order to explain this in depth. We will take an example of BeCl2. Which example, ma'am? Example I am considering of BeCl2. Now in the case of BeCl2, what is Be? Be is beryllium. What is the atomic number of beryllium, students? Hydrogen, helium, lithium, beryllium. Ma'am, atomic number is what? Atomic number is 4. Now, if beryllium has 4 atomic number, how will it be represented as? It will be represented as 1s2, 2s2. 4 electrons, 2 plus 2, 4 electrons, right? Let us represent it. It is 1s contains 1 and 2 electrons. 2s contain how many electrons? 1 and 2. Now, you have to combine 2 chlorine with it. Over here beryllium has, does beryllium has over here any unpaired electron? No, ma'am. They are paired. Paired means when there is a sum of 2 electrons. No, ma'am. It does not have any pair in a single orbit I am talking about. They are paired. They don't have any unpaired. That means, let me tell you, this state is the ground state. This state is the ground state, students. Now I am going to write which state, ma'am? Excited state. Which state, ma'am? Excited state. Why excited state? Because I actually require 2 more unpaired electrons in order to create a bond with chlorine atom. So what I am saying is, here 1s2, 2s2, here next orbital will be 2p, here we have 0 in 2p, no electrons in 2p. Now what will happen in excited state? In excited state, ma'am, this electron from s orbital will move on to the p orbital. This will go into the p orbital. I am just writing the outermost configuration. So 2s will contain 1 electron, and ma'am, 2p will also contain 1 electron. Yes, now this is the excited state. Now 2 chlorine can come and show bonding with them, but do remember here 2s and 2p have different energy. If you are going to obtain any geometry, any shape, they should have same energy. Then only hybridization is possible. So now what we are going to do, they will now undergo hybridization in order to attain same energy and to develop a certain, geometry. When they will attain same energy, they will be referred to as degenerate orbitals, or they will be referred to as hybrid orbitals. Now hybridization is basically the intermixing of atomic orbitals. So here intermixing will occur. Here intermixing will occur, and when intermixing will occur, they both will combine. Now which two orbitals are combining? 1s and 1p. When intermixing of 1s and 1p, that means which kind of hybridized orbital will form? S and P. So sp hybridized orbitals are formed. What are formed, ma'am? sp hybridized orbitals are formed. That means now we will obtain two orbitals containing one electron each. This is what? This is sp hybridized orbital. Here two atomic orbitals combined and form two molecular orbitals. Got my point? Now what will happen? Two chlorine atom will come and show their bonding. How? I guess this is clear. Now here see students, what is the atomic number of chlorine, ma'am? 17. What will be the configuration? 1s2, 2s2, 2p6, 3s2, 3p5. Yes, everybody, let us draw this. Outermost only I am drawing 3s2, 3p5. In S we have 2, in P we have 1, 2, 3, 4 and 5. How many unpaired electrons? 1. Only one electron is unpaired. That means it requires one more electron in order to complete the octet, right? So how will it look like? First of all, you know how is sp, in shape. In actual, sp orbital is like this. When one s and one p combine, they are going to obtain 2 sp, right? So let us first of all draw the structure of beryllium. See, in the case of beryllium, 2 sp orbitals are obtained. Now 2 sp orbitals will arrange themselves like this. This is beryllium atom. This is which atom? The beryllium atom. Now what will happen? It contains how many electrons in the outermost shell now? It contains 1 electrons. Beryllium. Here, because it is sp, it contains 1 electron. Now what will happen? Now chlorine will come. Chlorine basically, students, here p orbital of chlorine contains 1, unpaired electron. Basically, if I am going to ask you, how many electron? 1 electron it requires. So over here, that 1 electron of P will create a bond like this. Now this is of chlorine atom. 1 electron is now sharing its electron with 1 electron of beryllium. So this shape over here, if you are going to draw it like this shape comes out to be which shape, ma'am? A linear shape. Which shape, ma'am? A linear shape. 180-degree angle. So BeCl2 is an example of sp hybridization. BeCl2 is an example of sp hybridization. Everybody, please write it down. Yes. Everybody, please write it down so that we can now move on to the next part. Similarly, you can write for BeF2. Done, students? Done? Shall we move on to the next part? Yes. Everybody, please complete that. Now, we are going to take the next example for sp2. An example is BeCl3. Shall we? Now this is p orbital of C. This is p orbital because it contains 1 electron. It requires only 1 electron, right? Now students, comes the second part, the second type, that is sp2 hybridization. See, in sp2 you very well know 1s and 2p are going to combine. What they are going to form, ma'am? They are going to form sp2 hybridization. We are going to take an example of BeCl3. Now over here we have boron with atomic number 5. We very well know. What is going to be configuration? 1s2, 2s2, 2p1. 2 plus 2, 4, 4 plus 1 is 5. Let us write the electrons of 2s2 completely filled. 2p1. Now, we want 3 chlorine atom to come and join with it, right, in order to complete this octet. So, this is again, ma'am, the ground state. What will be the excited state? That ma'am, in excited state, this one electron will jump and will move on to the p orbital. So what are we going to get? We will get 2s1, 2p2. Now, over here you can clearly see that we require 3 orbitals only in order to create a bond with 3 chlorine. So when 1s and 2p here, 1s and 2p are combining, are intermixing together, they form 1s and 2p, sp2 hybridized orbitals, sp2 hybridized orbitals. In actual, how are they going to be shown? See, this is boron. If I'll talk about, this is the structure. This is the first orbital, second orbital, third orbital. This is the structure for which atom? Ma'am, for boron. Now only we have seen in the case of chlorine, atomic number 17, that it has 1 electron. Basically, it has what configuration? If you will see over here, it has 3s2, 3p5, no? Sorry, I wrote 2 over here. It has 3s2, 3p5. Now, this 1p orbital contains 1 electron. So, that means this is p orbital of chlorine. This is p orbital of chlorine. This is p orbital of chlorine. Now, boron basically contained how many electrons in the outermost? 1, 1 each. This sp2 hybridized orbital contain 1, 1 each, and 1, 1 electron will be of whom, ma'am? Of chlorine. So, single bond, sigma bond is created over here, as you can clearly observe. Yes, everybody, clear now? So, over here, if you are going to see the geometry, first of all, create these X's. Now, students, just join them. You will see that we can draw this on a 2D plane. So, this creates which kind of a structure? Trigonal planar structure holding 120-degree angle each. So, BCl3 is an example of sp2 hybridization. Is it clear to each and everybody of you? Yes, students. Is it clear to each and every one of you? That's clear. Okay. Now, we are going to the third part, that is sp3 hybridization. Now, this somewhat we have already done. That is the case of CH4. When all the 3 p orbitals and 1 s orbital combine, it will form sp3 hybridized. Let us take an example of CH4, which has which geometry, ma'am? The tetrahedral geometry. Yes? Now see. Carbon with atomic number 6 has a configuration of 1s2, 2s2, 2p2, 2 plus 2, 4, 4 plus 2, 6. That means 2 in S and 2 in P. Now, it has only 2 unpaired electrons. That means it can form only 2 bonds. But here it is forming 4 bonds. That means, ma'am, this is ground state. Again, this is ground state. We have to write excited state. So, let's write excited state. So, in excited state, ma'am, 1 electron will jump from S towards P. So, what we will get? 1 in S and 1, 1 each in P. Yes, clear? Now, see, now we have 4 orbitals. That means over here, ma'am, 1s and 3p are combining. What is happening? 1s and 3p are intermixing all together. Intermixing to form sp3 hybridized orbital. How in actual it is going to look like? For example, this is carbon. I'm not showing the smaller lobe because that will be after the C carbon at back. Okay, in actual I'm showing you this. Now it is combined, each will have one electron, and hydrogen basically has 1s1 configuration, that means 1 in the shell. Hydrogen is spherical, 1s1 spherical, so 1 electron of hydrogen, 1 electron of hydrogen. So this creates which kind of a geometry? The tetrahedral geometry. Which geometry, ma'am? The tetrahedral geometry. Clear? Let's write down now. For next one, you don't have to create structures because I have already told you that is for sp3d. It is basically an example, that is we take over here is PCl5. For example, this is phosphorus, this is chlorine, 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 and one chlorine is over here, one is over here. So this is the structure that I have already told you, but yes, examples we have not written, so I am writing. sp3d2 example is SF6. SF6. So here is sulfur, one fluorine at the top, one at the bottom, now creating a square over here like this. Clear everybody? SF6. Now students, we are going to start with the question segment. Everybody first of all write it down. Take a minute and write it down. So now students, I guess everybody has written this right. Now we are going to start with the question segment as I have already told you. So here comes the very first question, students. Let us discuss this one by one. First question is, match the molecules given in column 1 with their shape given in column 2 and mark the appropriate choice, right? So we have been given the names over here and the structures over here, and we have to match and we have to check which of the following is the correct one. So in this match the following, first of all let us see. We have been provided with SF6. Now only we have done this, right? SF6 holds sp3d2 geometry, that means octahedral nature. So we have just seen sulfur over here, all the fluorines, 4 fluorines here and one at the top, one at the bottom. That means A goes with D or the fourth option, I would say. So A goes with fourth option. Here A is in third option, wrong. A is in fourth option, A is in second, this is wrong. So either it can be A or B option. Let's move further. Yeah. We have been provided with SiCl4. SiCl4. You can clearly observe this. 4 chlorine atoms attached. So this comes over here, SiCl4. That means B with the first one. B with the first one. That means it's incorrect. We have option number B as the correct one. That means SiCl4 holds sp3 geometry with the tetrahedral shape, right? With the tetrahedral shape. Yeah, moving on to the next one, AsF5. Yeah, so basically it holds this geometry. Here this is going to be As, this is going to be the fluorine atoms. Yeah, and the last one is BCl3, which holds trigonal planar geometry, the third part. Yes, everybody. So answer here comes out to be, ma'am. Answer here comes out to be, ma'am, option number B. Clear, simple question. Let's see the next one. Next one is, which of the following does not show octahedral geometry? Now, octahedral geometry, my dear students, is the one which basically holds which kind of hybridization, ma'am? sp3d2 kind of hybridization. And if I'll talk about this hybridization, we can clearly observe that among all of them, SF6 so we have seen is octahedral. IF5 is also octahedral in nature, students, if you are going to observe the geometry. Then is SiF6 minus 2, this also holds octahedral, but SF4 does not hold octahedral. It has only fluorine atoms, 4 fluorine atoms attached to it. If you are going to draw the structure, this is not an octahedral one. So answer is option number D. Let's move on to the next question. In the BCl3 structure, they are talking about, the BCl3 is a planar molecule, whereas NCl3 is a pyramidal because A option, BCl bond is more polar than NCl bond. So if you will talk about BCl3 structure, it is trigonal planar structure. Okay, you can draw it on 2D. Whereas NCl3 is a pyramidal in shape. Why is it so? See, first of all, read the options, then I'll let you know, then you will think about it. A is BCl bond is more polar than the NCl bond. B is NCl bond is more covalent than the BCl bond. C is nitrogen atom is smaller than the boron atom, while D is BCl3 has no lone pair but NCl3 has a lone pair of electron. Understand, students, if we'll talk about the boron, basically it can create 3 bonds, right? 3 valence electrons. In case of nitrogen, it has 5. So if 3 are involved in bonding, 2 electrons are left as a lone pair of electron. So if it has a lone pair of electron, if you keep hand on that lone pair of electron, it will be creating a pyramidal shape. So hence option number D will be the right one, that BCl3 has no lone pair of electron, while NCl3 has a lone pair of electron, due to which NCl3 is pyramidal in shape. So option number D among them is going to be the right answer. Done. Okay. Next question is, structure of XeF4 basically is going to be what? XeF4 basically, A is square planar, B is triangular, C is tetrahedral, D is octahedral. Just think about it, students. In such cases, you should first of all know that to which family does it lie. To which family does Xe lie? You will get your answer over here directly. Xe is xenon, basically the inert gases. Helium, neon, krypton, argon, xenon, all of these are the inert gases. 8 electrons we are talking about. XeF4 we are talking about. If 4 electrons are involved in bonding, there will be, you can see the lone pair of electrons also over there. So it is square planar structure. Square planar structure. If you are going to see, it forms a square planar structure. A option is the right answer. Next question. Which of the following statement is not true? A. Ionic bonds are non-directed while covalent bonds are directed. B. Formation of pi bond shortens the distance between two concentrated atoms. C. Ionic bond is possible between similar and the dissimilar atom, while D. Linear overlapping of atomic orbital leads to sigma bond. Now this is your first homework question for today's class. Just think about it once what we have done, right? You will get your answer over here. Just think what we have studied in this session, in the previous session, you will get your answer. Let's read the next question. Which of the following orbitals will not form sigma bond over overlapping? Now, when they have not provided you internuclear axis, students, you have to consider that, ma'am, internuclear axis over here is the Z axis. Just consider that if they have not provided you. So starting with one by one with all the options, let us say with A option I'll go with. If you have this as my Z axis, I have S orbital and an S orbital overlapping. So when they're going to overlap, they will form like this, and it is a formation of sigma bond. They are forming sigma bond. It cannot be A option. Let us see the B option. In B option, S orbital and PZ. See, internuclear we are taking Z only. S orbital and the PZ. So this is PZ. So when they are overlapping, so this is again the formation of sigma bond. Hence again here sigma bond is seen. So this is not the right one. Let's see the C part. PZ and the PZ one. Again this is Z. This is PZ. This is PZ. So when they are going to overlap, like this, again this is the formation of sigma bond. So that means this is also not the right one. We have got our answer D, but let us draw that as well. So this is again the internuclear axis. Here we have PX. Let us consider this as an X and X axis. So this is PX, this is another PX. When they will combine, what are they going to form? They are going to combine in such a way that over here there are two overlapping regions. That means this is the formation of pi bond. So D option is the one in which it will not form sigma bond after overlapping. Is it clear to each and every one of you? The shaded region over here in all the cases is the overlapping region. Clear? Let's see the next question now. Which type of overlapping is shown by P, basically PX, PY and PZ orbital? See, let me tell you. If you are taking PX on Z axis, you have to see over here that what kind of overlapping is seen. See, let us consider we are taking PX on Z axis. You will obtain what? Again sideways overlapping. That means pi bond formation. If you are taking PY on Z axis, again pi bond. But if you are taking PZ on Z axis, it is sigma bond. So one sigma bond and two pi bond. That means two sideways and one end to end. So two sideways and one end to end overlapping. Getting my point? Z you have to take as an internuclear axis. So PX and PX on Z will be like this. PY on Z will be also like this, but PZ on PZ will be like this. That is axial one. So one axial, two sideways, that means two sideways and one end to end. End to end is basically the axial ones only. So B option is the right one. Next is propyne molecule contains, propyne molecule. Okay. If yne word is root, that means it refers to as triple bond. So it is basically CH triple bond C CH3. So how many sigma bonds does it have and pi bond? See, first bond initially is sigma. This is also sigma, and one with 3 hydrogens are also sigma. So 3 over here with hydrogen, 4 5 and 1 with this hydrogen, 6. 6 sigma bonds, 6 sigma bonds. How many pi bonds you can clearly observe? Second bond is pi bond, ma'am. Third bond is pi bond. So 2 pi bonds. That means, ma'am, option number A over here is your right answer. Clear, easy question, no? Let's see in the next one. We have, which of the following statement is true about hybridization concept now? A option is the hybridized orbitals have different energies for each orbital. B option is the number of hybrid orbital is equal to the number of atomic orbital that are hybridized. C is hybrid orbitals form multiple bonds, while D is orbitals with different energies undergo hybridization. So they are asking us a true statement, true with regard to hybridization. Let's start again with option A. The hybridized orbitals have different energies for each orbital. No. Always remember, atomic orbitals can have the different energy, but hybridized orbitals, when they are intermixed, when the atomic orbitals intermix, hybridized orbitals are created which have same energy. So over here they will have same energy. This is incorrect. Let's see the B part. Number of hybrid orbital is equal to the number of atomic orbital that are hybridized. So true. This is the correct answer. Always remember, if you are intermixing 2 atomic orbital, you will get 2 hybridized orbital. If you are intermixing 3 atomic orbitals, you will get 3 hybridized orbitals. So the number of atomic orbitals that you are intermixing will produce the number of hybridized orbitals over there. Do remember this key concept. Clear? Okay. Let's see the next one. Which of the following molecule is formed by sp2 hybrid orbitals? sp2, sp2, 1s and 2p. Now answer is here, which we have already done in class right now, few minutes back. sp2 hybridization was seen in the case of BF3. If you remember, 3 hybridized orbital. sp2, 1s, 2p, that means sp2. So sp2 contains 3 hybridized orbital. 3 hybridized orbital, if you remember, it creates somewhat this kind of geometry, which is trigonal planar geometry. Yeah, so this was the structure of, not like this, this was the structure of BF3. Yes, everybody, we have taken a case of BCl3, so BF3 is the right answer over here because there are 3 hybridized orbital. sp2, 1s, 2p, 3 here lies for BF3. Clear, everyone? Shall we see the next one? Which type of hybridization is shown by the carbon atoms from left to right in the given compound? Now we have been provided with CH2, double bond CH, single bond C, triple bond nitrogen. See, always remember, I already told you in the case of carbon atom, count sigma bond and the bond pair, lone pair, sorry. Sigma bond and the lone pair. Don't count the pi bonds. If the sum of sigma bond and lone pair comes out to be 4, hybridization will be sp3. If the sum comes out to be 3, hybridization will be sp2. If the sum comes out to be 2, hybridization will be your sp. Yes. So coming over here, see, carbon basically form 2 bonds with hydrogen and 1 sigma bond with this carbon. Pi bond you don't have to include. So 2 plus 1 is 3. For 3 it is sp2. So first carbon has an sp2 hybridization. sp2, sp2. C and D are wrong. Let's talk about the next one. This carbon making 1 sigma bond over here, 1 sigma bond over here, 1 over here. 3 sp2 yet again. sp2. Let's talk about the third one. This carbon, 1 sigma, another sigma. These two are pi. Second bond is pi, third bond is pi. First single bond is sigma bond. 2 bonds, so hybridization is sp. That means option number A over here is correct answer. Everybody, first of all, write it down so that we can now move on to the next part. First of all, please write it down. Done? Yes, done? Okay. Here comes the next question. On hybridization of 1s and 3p orbitals, what do we get? A option, 4 orbitals with tetrahedral orientation. B option, 3 orbitals with trigonal orientation. C option, 2 orbitals with linear orientation, while fourth is D is 2 orbitals with perpendicular orientation. See, they are saying 1s and 3p. They are forming sp3. And sp3 basically contains 4 hybridized orbitals, 4 orbitals with tetrahedral orientation. sp3 basically, students, have a tetrahedral orientation. So among them we are getting 4 orbitals with tetrahedral orientation. Hence answer over here will be option number A. Answer over here will be option number A. Very simple. A direct question I would say. Yeah. Okay, let's see the next question now. Next question is, the molecules like BRF3 and XeOF4 are square pyramidal in shape. What is the type of hybridization that is shown in these molecules, students? So, this is your second homework question for today's class. Just see how many bonds they can create. That's it, you will get your answer. A is DsP3, B is DsP2, C is sp3d, while D is sp3d2. Okay, no worries, there are some part of hybridization still left, but yes, you can try this out. Moving on to next question. Which of the following shows DsP2? Still we have not done this kind of question, but yeah, DsP2 we have not started yet, we'll be doing in the next class, so I'm just skipping this question. Next question is, which of the following pairs are isostructural? Let's wait for this as well. Let's see the next one. 1 second, students. I am just removing the questions that we have not yet done so that you won't get confused, right? Yeah. Now comes the next question. Given below is the bond angle. They have provided you over here the bond angle in various types of hybridization. Mark the bond angle which is not correctly matched. Okay. So A option is DsP2 holding 90-degree angle. B option is sp3d2 holding 98-degree angle. C option is sp3d holding 90-degree angle, while D option is sp3 holding 109.5 degree. So this is your homework, third homework question for your today's class, my dear students. Right, everybody, this is your third homework questions for today's class. Now the next homework question that I am giving you over here is, students, fourth homework question as, draw the structures for hybridization sp, sp2, sp3, sp3d and sp3d2 by taking different examples. The examples that I have provided, don't take that examples, take a different example, see from NCERT, from back questions, and draw different structures. Try the structures by your own. Try them by your own. But yes, do that. Next part is question 5. Solve NCERT back exercise question. The exercise question which we can do right now. Start solving it. In the next class, students, let me tell you now only. In the next class, we shall be reading some NCERT highlight again, as we used to do in all the classes. After that, I shall be discussing the important questions of NCERT in-text and the back exercise. The important ones. So, if you have any doubt in NCERT in-text question or NCERT back question, you can just write in the chat section. I'll see that and I'll consider that and I will be doing it further. Right, students? So now we are going to end our today's class over here. I hope so today's class was helpful for you. These all were structure based questions, so the lecture was a bit smaller than the previous ones. But yes, in the next class we will be doing the very most important topic of ours. So don't miss that session. I shall be meeting you in the next lecture. Till then, keep smiling, keep learning. Thank you so much and have a good day, my dear students.